Example 5. Monosodium glutamate, a flavor enhancer in certain foods, contains 35.51% carbon, 4.77% hydrogen, 37.85% oxygen, 8.29% nitrogen, and 13.60% sodium by mass, and has a molar mass of 169 gram per mole. A. What is the empirical formula of MSG? B. What is its molecular formula? First, we will summarize the most important information. Numbers with units and what we are looking for are considered as the most important information. If there is a chemical reaction, a balanced chemical equation is also considered as the most important information. Next, let's conduct some analysis to see how we can find a solution for the given problem. In other words, we need to find a way to link what are given to what we are looking for. First, let's refine our goal. From the problem, we know that the compound contains carbon, hydrogen, oxygen, nitrogen, and sodium. To find the empirical formula means we need to find the values of X, Y, Z, M, and N. X, Y, Z, M, and N are the smallest whole number moles of the corresponding element in the molecule. To find the molecular formula means we need to find the value of K. K is an integer number. K can be 1, can be 2, can be 3, etc. Then let's look at what we are given. We are provided the percentage of mass of all elements. Then let's look at the definition of the percentage of mass. Let's use carbon as an example. The three-line symbol represents this is a definition. There are two definitions of the percentage of mass of carbon. The first definition is the gram of carbon in the compound divided by the gram of the compound, multiply 100%. The second definition is the gram of carbon in 1 mole of the compound, divided by the molecular weight of the compound. Let's look at what we have. We already know the percentage of carbon by mass. We don't know the gram of the compound. But if you look at what are given, you can find the molecular weight of the compound. As we can see here, if you know the percentage of carbon by mass and you know the molecular weight of the compound, you can find the gram of carbon in 1 mole of the compound. If you remember, we can convert the gram of carbon into moles of carbon if we know the atomic mass of carbon, which you can look up from the periodic table. By definition, the number we calculated, which is the moles of carbon in 1 mole of compound, should be equal to the value of Kx. We can use a similar method to find Ky, Kz, Km, and Kn, because we know the percentage of each element by mass in the compound. After we find all the values here, and we can find the molecular formula. If we know the molecular formula, we can find the empirical formula. Kx is K multiply X. Kx is not one symbol. Now let me show you the work, the details of all steps. When I rewrite this definition, it will help me to remember it. From our calculations, we can find the molecular formula. From the molecular formula, we can find the empirical formula. This is already the smallest whole number moles ratios. So the empirical formula is the same as the molecular formula. Can you follow my example to work out this problem by yourself?